24, question 51. Consider the line integral, this one right here, where this vector is defined. Of course, this is a very Cartesian coordinate, very standard definition. And the path C is given by this function right here, this path function right here. So what is basically happening is, let's assume this is the fluid flowing in this direction, which is defined by this RT function here, which is defined by this RT function here. Fluid is flowing in like a helical spiral upward winding trajectory. And let's say we have injected some dye, we just injected a dye particle right here. So so that is my T is equal to 0. So that's what when the dyes had injected, and we have to do the integration on this path from 0 to pi, 0 to T to pi. That's what we have to do the integration. When of course T is equal to pi by 2, the die is rotated like the quarter, and it has also risen like halfway around here. When T is equal to pi, it has made a kind of like a full turn in the sense as a half of the rotation is a half of rotation here, half rotation here, and it's the end of the trajectory. And along this one, as the die moves, it experiences a force along the direction, along this direction. And so this integral represents the amount of energy that has been transferred by the flowing fluid to the die particle. So it's practically actually also the work done. So this is really the work done. We know that's by definition of this dot product, right? So this is like dot product of these two vectors. So that's what we have to find out. So T is like a path parameter. It's not exactly the time. It's like a slider, so it just moves along. The rotation as well as the trajectory or the height of the fluid keeps on changing. So anyway, so we have to evaluate this particular integral right here. So how will we do it? So this is a very standard formula. In this is the dot product. If we do that, so between the limits right here 0 to pi, this is the function right here, and we have to take the derivative of this path function dt. So that's by definition. That is by definition, and the details of this is given in my website here. So by definition, this is given, and this is also given. So this is like a x, and this is like this is like a z. So f RT would be equal to in place of x we write cos t, and in place of y we write sin t, and in place of z we write t. So that's what it is. Also, we need to find out the derivative right here, which is very easy from here. So we found out the derivatives, and then what we have to do, we have to take the dot product of this one and the between these two vectors, and we know I dot I is of course equal to 1, I dot j is equal to 0. So all those things we know. So basically, the term that will be left is equal to negative of cos t and sin t, and positive of sin t cos t. That will just cancel out, and t and k dot k would be equal to 1. So this is just t will be left. So this would be an integral of 0 to pi t dt, and we do the value be 4.934. So that's basically the answer. All the details of these calculations are given in the website.